Hello everyone, this is Group D6 from Vishwakarma Institute of Technology presenting you an informative video on the topic Use of different buses in von Neumann architecture. These are our group members. I am Shane DeCosta and I am going to give you basic information on bus, types of buses and address bus. Now let's begin with what is a bus. The electrically conducting path along which data is transmitted inside any digital electronic device is called a bus. It is basically a system that computer devices use to communicate or transfer data between each other. A bus consists of multiple pathways or lines. Each line is capable of transmitting signals representing binary digit 1 or 0. A bus can be unidirectional or bidirectional. Now there are three types of buses: address bus, data bus and control bus. So what is an address bus? The address bus carries memory address from the processor to other components such as primary storage and input-output devices. It is unidirectional. So in the diagram we can see that in order to read or write data or fetch and write data, the CPU needs to tell the RAM where the data is located. It does this by sending the address of the data to the RAM through the bus. It is unidirectional because only the processor needs to tell the RAM where the address is, but the RAM does not need to communicate with the CPU.
Let's move on to the use of address bus. The address bus is a communication pathway that carries memory addresses from the processor to the memory. In other words, it is a set of wires that allows the processor to specify the memory location where it wants to read or write data. The width of the address bus determines the maximum memory capacity that can be accessed by the processor. Let's take a closer look at how the address bus is used in the von Neumann architecture. The address bus is a component of the memory system in the von Neumann architecture. It is used to transmit memory addresses from the CPU to the memory subsystem. When the CPU wants to read or write data from memory, it puts the address of the memory location on the address bus. The address bus is typically a unidirectional bus that carries address signals from the CPU to the memory subsystem.
We can discussing about what is the database. Database carries data between processor, the memory unit and the input output devices. Uh, Diagram of database transfer data to send from the memory to computer or into or output of the central processing CPU unit. The act as the devices is called engine.
Hello, I'm Dev Datir and I'm going to explain you the uses of data bus in von Neumann architecture. So as earlier explained, data bus carries data between the processor, the memory unit and the input output devices. Looking forward to the uses of data bus, the data bus is a component of memory subsystem in von Neumann architecture. The data bus is one of the lines on this bus along with the address bus and control bus. The data bus is typically bidirectional, allowing data to be transferred in both directions between the CPU and memory subsystem. The number of lines on the data bus determines the maximum amount of data that can be transferred between the CPU and memory in a single cycle.
After the address bus and data bus, next bus is a control bus. A control bus is a computer bus that is used by the CPU to communicate with devices that are contained with the computer. This occurs through physical connections such as cables or printed circuits. Control bus is used to determine data processing. As you can see the diagram, the control bus is a bidirectional. Communication between the CPU and control bus is necessary for running a proficient and functional system. Without the control bus, CPU cannot determine whether the system is receiving or sending data. It is control bus that regulates which direction write or read information need to go. The control bus contains the control lines for write instructions and lines for read instructions.
As explained earlier, control bus is a type of a computer bus that carries control signals between various components of a computer or electronic system, and that the control signals are the signals used to control the operation of various components like the CPU, memory, and I/O devices. Now, before moving on to the uses of control bus in the von Neumann architecture, let me just brief you about what von Neumann architecture is.
So the von Neumann architecture is a type of computer architecture that is based on the concept of a stored program computer, which basically means that the instructions and data are stored in the same memory and the same bus is used for transferring data and instructions. Now moving on to the uses of control bus in this architecture. The first one is an important one, which is the role of control bus in the fetch execute cycle, a fundamental cycle in this architecture. So how is this cycle executed? First is that the address of instruction which is stored in the program counter goes to the memory address register MAR. Then the address which is stored in the MAR then goes to the instruction register IR, which is then further passed to the instruction decoder, and then execution of that instruction is done. So now the result which is obtained after the execution of the instruction is then stored in the memory. Now you may ask, why an instruction decoder is required? So the instruction decoder is required because the instructions stored in memory are typically in a binary format that is not directly executable by the CPU. So the instruction decoder reads the binary instruction code from memory and interprets it, determining which operation needs to be performed, what data needs to be accessed, and how the data should be processed. The instruction decoder then generates control signals that are used to control the other components of the CPU, such as the arithmetic logic unit, which is the ALU, the registers, and the memory interface. So we can clearly see that the use of control bus is seen in the instruction decoder. Now the other uses are that the control bus is responsible for transmitting control signals such as the address of instruction to be fetched, the data to be written to or read from the memory, and status signals. It also helps to control the flow of data, instructions, and ensures that each step is executed correctly. Also, the control signals are used to synchronize the activities of different components and to ensure that instruction and data transfers are done correctly.